Okay. Good morning, ladies and gentlemen, or good evening, ladies and gentlemen. I'm quite glad to be here from you again after a big break or big holiday, if you prefer. Uh, I'm going to continue our lecture course about system software design. However, I will be doing that in the remote mode. I will be recording my video presentations so that you are able to watch my video lectures at any time, interrupting it and coming back to it. Probably this is a little bit more convenient for you than to just to come at a particular time and to listen it or watching it in a particular time. Anyway, let's start for today. Let me remind you that our course is about software systems design, or simply speaking, we are considering various design patterns. What is design patterns? Let's quickly consider it. I will remind it to you. I am doing it at the beginning of each talk, of each my talk. So design pattern is an architectural scheme. Look, architectural scheme or idea or approach, how to organize classes, objects, and methods to solve a kind of solve a problem that you are going to work with. My typical approach is that first I describe you a problem and then consider how to solve this problem using that or that pattern. Another point I would like to remind you is that everything we are talking about is related to object-oriented approach. So we will be using typical object-oriented notions like class instance, inheritance, virtual functions, or polymorphism, etc. So don't forget about that. We are within object-oriented paradigm. So let's, this is the taxonomy of design patterns. Simply speaking, there are three main categories of design patterns: creational, structural, and behavior. Again, you will read this by your own. This is just to remind you about such a taxonomy. And this is the remind what did we consider before. Again, I wouldn't read everything on this slide, just read it by your own. Let me remind you only that we have considered we have considered not patterns as per se, but some principles or language mechanisms that are actively used within the idea of design patterns. That is RAI principle, resource acquisition is initialization, new C++ features like default and delete, and we have considered a few concrete patterns like singleton strategy, decorator, etc. Again, look at my previous slides to see the details of them. I suspect that you have already forgot some points related to those patterns, and I would highly recommend you to come back to the previous slides. And now we will go to the next, to the topic of our current talk. We will consider two very interesting, relatively simple, and very popular design patterns. They are called proxy and bridge. In short, this slide contains short description of those patterns. Proxy is how to define a representative for another object without changing its interface. the key word here is representative or placeholder, or for those of you who understand Russian, I could say that this is a kind of посредник between between the two classes. This is not that difficult to understand. We will consider it using examples. And the second pattern is bridge. It is a little bit more serious pattern, but it is used very, very often because it is very useful in practice to decouple an abstraction from its implementation. This looks a little bit trivial, perhaps, but again, it is very, very useful. We will see that later today. So let's start with proxy pattern. Again, probably I should move this picture of myself somewhere here. And look, pattern proxy. Perhaps the simplest pattern ever because it is implemented in a very simple manner. However, it is quite useful. So there are various aspects of using proxy. First, to create a local representative for an object located in a different address space. It is very often that we use such a representatives in our programs. Probably the most interesting example is that we use so-called file identifier in our program. The file is an object located on a disk space or somewhere outside our computer, or not not in memory. And in our program, we have a local representative for that. Such a proxy use called remote proxy. Another example is so-called virtual proxy. It is to organize access to an expensive or heavy-weighted object on demand. Keywords here are heavy-weighted, that is, a big objects with a lot of data inside, and it is very often not reasonable to load the whole object in advance because we cannot expect whether we will use that object actually or not. So in order to organize access to such an object on demand at the moment when it is actually needed. So again, pattern proxy is successfully used for that purpose. Another case is to control access to the original object. This is especially useful when objects should have different access rights. Okay, this is also quite an often use case of proxy. And finally, probably the most interesting, practically interesting thing is so-called smart reference or smart pointers. This use case of proxy is very interesting. We can organize more smart control on objects. Simply speaking, we can allocate memory for object, and we can count references or just number of references to that object. And if we do not have such, if we at one moment while program is running, if we have no references to that object, we can delete it from the program without any negative consequences. And again, smart pointers or smart references also can be implemented using proxy pattern. Okay, so these are just examples or use cases for proxy. Someone can understand that proxy as a design pattern looks a little bit similar to some patterns we have considered before. In particular, there are adapter and decorator patterns that look similar to proxy. However, it is very important to emphasize differences between these design patterns. For example, adapter, this is a very important moment, provides a different interface to the object it adapts. This is the idea behind adapter. In contrast, a proxy provides the same interface as its subject. This is the idea, the main idea in proxy, to provide different interface, to provide the same interface and to add some additional functionality. Decorator have similar implementations as proxies, but they have different purpose. This is the key point, the key difference between proxy and decorator. Decorator adds one or more responsibilities to an object, whereas proxy controls access to an object. This is the point. This is very important. Well, just important point. Okay, so this is time for us to consider how to implement proxies. Look at the slide. Here we have just two classes. The first class is the class to which we are going to implement a proxy or placeholder. The second class is the placeholder or proxy itself. This is a very schematic example. Look at it carefully. Three observations or three kinds of reasonings about this, this pair. First, object and proxy, these two classes are completely independent from each other. There is no inheritance relations between them. Technically, the second point, technically, proxy contains a pointer to the object that it is controlled. The reference or pointer to the object class is implemented as a private member of proxy. And the idea is that each access to object via proxy is just redirected to the corresponding member of object. Now it looks a little bit cryptic, probably because this is very schematic illustration. But next slide, on next slides, I will provide you with more detailed explanation. Now it is important to emphasize the point that these classes are independent. The communication between these two classes is organized using pointer to object. Proxy just contains the pointer to the object it is the placeholder for. Okay, and the third point here is that interface both object and proxy is the same for both classes. And the consequence or the desired wish is that proxy should behave exactly as object. This is the point. Again, I will explain it in more details on the next slides. Look, the third point, again, interface of both object and proxy should be made the same so that the second behaves exactly like the first. Simple question, how to achieve that? How to do that? This is not a kind of trivial task. So how to make proxies interface the same as objects interface? Let's consider this interesting point next. So next two or three slides are as kind of side-off slides. Here we are talking about the C++ language, the main implementation language we use for design patterns. Look, how everything, not everything, how design patterns or proxy pattern should be implemented or is implemented. Two key points: member access notation and operator overloading. These two basic C++ features are used for implementing real proxies. Let's consider the first point, member access notation. This is a relatively simple thing. It should be quite clear to you. Look, how do we access to members of classes? We have basically two ways: using the name of the object or class instance and using the pointer to an object, to a class instance, okay? Depending on these two things, name of the object or pointer to the object, we use either dot notation or arrow notation. Well, I don't need to repeat it again for you. I guess I expect that you understand that quite well. This is syntactical notation. Again, we use either dot or arrow to get access to class instance members. Okay, and the relationship between these two ways is illustrated under the point 3 on my slide. So by definition, the access to a member via pointer is the same, by definition, is the same as the construct I have written on the slide at the right side. So look what we are doing. We are taking pointer to an object, to an instance. We apply dereferencing operator to it, getting the object itself using that pointer. And we apply dot notation to get access to the member of that instance. Again, I expect that you understand this equivalence, this formula. Well, if you are using, or if you were using any other language, for example, Java or C#, you might remember that there is no arrow way to access object. We do not have pointers on those languages, but internally the idea is exactly the same, because reference types in Java and C# are technically or internally are the same as pointers to those types. Okay, anyway, this is the first feature we will be using while implementing proxy pattern. The second feature is a little bit more complicated, but much more interesting. So look at the next slide. The second feature is called operator overloading. This is a relatively big example illustrating this. I will have some comments on this slide. So look at the comment at the left side. The idea is to enable class objects or class instances to behave exactly like objects of fundamental types. Simply speaking, suppose we have two integer objects, okay? What can we do with those objects? The answer is quite simple. We can apply additional operator to those integer objects. Simply speaking, we can write a plus b, where a and b are objects of integer types. This means that plus operator is predefined for integer type. The same is for doubles and some other types. Whereas we do not have similar direct support for objects of class type. Simply speaking, if we have two objects of a class type, for example, C1 and C2, we cannot perform addition to, in general, we cannot write C1 plus C2, just because plus operator is not predefined for class instances. This is the point. And the C++ language supports very powerful and interesting feature. It is possible to add some operators to classes. Look at the slide as the example on the slide. We use a special notation, operator, keyword operator, and the sign, operator plus, in the first example. This declaration looks like a usual function or member function or method. The exception is that the name of that method looks a little bit unusual. Instead of usual name of a function, we use this construct, operator, keyword operator, and the sign. Conceptually, it means quite a simple thing. We say that it is possible to perform plus operator on objects of type C, where C is the name of the class. So, and if you look at the line with addition, where we declare some variable, we initialize it with operator, with the operator plus. That is, we say that some instance of class C is initialized by the result of addition C1 and C2, where C1 and C2 are class instances. This is by definition correct, legal, because we have operator plus defined for objects of that class. So in the comment at the right side of this declaration, you can see how this operator is implemented by the C++ language. This is the result of application that function for C1, passing the C2 as a parameter. This is very powerful and wonderful feature, and we'll be using it for our considerations further. Another point, another fundamentally interesting point is that not only usual arithmetic or multiplicative operators can be overloaded. Look at the last two method declarations in the C class. Operator with empty parentheses and operator with empty brackets are declared as method in class C. Empty parentheses mean function call. Brackets mean indexing. The idea is that both function call and indexing or indexation are treated as operators on some arguments. Well, let's consider indexing. We use two elements when we write the construct using brackets. We use in a simple case, we use the name of an array, and we use the second argument as the number of the element of that array we are going to access to. So again, this is the basic thing. Not only usual operators, but such operators as call and indexing can be overloaded. Again, this is all about instances of a class type. Look at the next slide. This is the common syntax of such a operator function declaration. Well, the example was given on the previous slide. This is just just for your reading, and some rules related to operator overloading. There are some restrictions on operator overloading. Arity and preference shouldn't change. That is, if we have multiplication, if we are going to overload multiplication, as you know that multiplication assumes two arguments. So your version of multiplication should also have two arguments. The next point is it is not allowed to introduce new operators. That is, we have a predefined set of operators like plus, minus, etc. This is quite a big set of predefined operators. And the second restriction is that we cannot introduce our own operators. We should stay within the predefined set of operators. However, look at the third point. Many predefined operators can be overloaded or redefined. Even such things like indexing, as I've shown you before, function calls, new and delete operators. And finally, there are two operators in this set that are especially interesting for us, for our purpose. Don't forget that we are going to discuss the implementation of proxy. Look, there are operators star, arrow, that is used for for access to instance members via pointers, and star operator, that is dereferencing. Both operators can be overloaded for classes. Notice that dot operator can be overloaded. However, we have quite a replacement for that, as was shown on the formula on one of the previous slides. So let's come back to proxy implementation. Look carefully at what I have written here. Let me move my window here. So look, this is the more detailed version of our pair, of our wonderful pair. Two classes, object and proxy. Proxy should be made as a replacement for or placeholder for object. And look at two operators in proxy, star and dereferencing. So the idea is that each time we get access to proxy using these operators, actually the corresponding functions are used instead. Let me show it to you on examples. Look, interesting point. So we declare on this use case, we declare P as a member, as an object of class proxy. We initialize it by the pointer to some object instance, okay? Because the corresponding constructor in proxy assumes that it should be initialized by this point. Okay, very good. And after that, we can use this proxy P for getting access to elements of class object. And again, each access to object is done via proxy. And having these two operators overloaded, star and arrow, we can automatically get all access to objects interface, to the interface of class object. The two lines in the middle of the use case show that. If we write P arrow M, this automatically means that we call operator star or operator arrow for M. Look at the comment in green. This is by definition the same. And the second line shows a similar thing with dereferencing operator. The first line is for modifying the value of M, which is in public interface of object. And the second line is how can we read that value. Oh, okay, so this is the key point. I will emphasize this again. If we overload these two operators, arrow and star, in proxy, we automatically get access to all interface members of the object for which this one is a proxy. Conceptually, this is simple. I would recommend you to write a very simple test code like as written on the slide, and to check how it works. Now I would like to emphasize one point. Look at the last declaration of P1. I have declared P1 as also a proxy. However, I have initialized that P1 object by null pointer. Okay, it is completely legal, because I should provide any pointer to this object, to this declaration, just because the constructor of proxy assumes accepts a pointer, and null pointer is automatically a good replacement for any pointer. So this is syntactically well, this is legal by the from the language point of view. However, it is definitely erroneous because we cannot use P1 for getting access to another object, because we don't have one. And now I would come back to the class proxy as it is defined on my slide. In this way, the proxy is quite useless. It performs no real actions. Look, it just redefines two operators, nothing else. And, which is probably even more important, it doesn't prevent access to null pointers, as I have explained just now. So in real practice, we need a more realistic and at the same time more safe example than shown on this slide. So again, this slide is actually a scheme of how proxy can be implemented. Look at the next slide, which has more realistic example. Look, what is the idea behind this example? Suppose we have a class. I have called it very heavy object. Very heavy object means that this is the instances of that class are quite big, and so loading them or creating them in memory takes a lot of consumes a lot of resources. So the idea is to ensure that such the instance of such an object gets loaded to the memory only when it is really needed. Okay, so I have written the proxy for that heavy object that performs such loading on demand. Okay, look carefully at what I have written. So again, two overloading operators, arrow and star, as on the slide before. However, the semantics of these overloaded operators is a little bit more complicated. In particular, before returning object for which we are using this proxy, it performs loading it to memory. And before loading, we should be sure that this object haven't been already loaded. Only in that case, we perform new operator. We actually create that very heavy object in memory. Only after that, we can have access to that object using star and arrow operators. Okay, so look carefully at this example. It is much more realistic, and many real code contains some similar things. Okay, that's basically it about basically about proxy. Why this proxy is used? A couple of comments. It postpones creating host object until the first access to it, as I have already said, and it ensures that access is always legal. We just cannot access to null object because there are no null object in our code. The very first access to star or dereferencing assumes loading object to memory if it is not already there. Okay, that's it, and a kind of exercise for uh, for uh, for proxy design pattern. So this is not as a task. So this is not obligatory for you to do that. But I highly recommend you to just to try uh, doing something like is written here. So first point is taking the code from the previous slide as an example, implement smart pointers. Look at some of the starting slides. I mentioned this use case of proxy. Organize counting the number of references to the real object. This is often called ARC technology, or automatic reference counting. And trying to ensure that the object with no references gets freed automatically. Okay, these are two related subtasks in this exercise. And the second task is also quite an interesting one. I would ask you to think how to implement proxy in a language other than C++. Probably you know that not all languages support overloading operators like star and dereference, arrow and dereference. So think about how to implement such a proxy in languages other than C++. So this is quite an interesting task, but well, I would recommend you to think about it. And now we come to the next pattern for today that is called bridge. Let me make a short break.